All right, welcome to the first video for section 3.1. In this section, what we're going to do is we're going to look at solving quadratic equations. So last chapter we talked a lot about the different properties of quadratic equations and their graphs and how to interpret and analyze them. Here we're going to talk about how to solve equations. Now, just a reminder, when you're asked to solve an equation, so let's say our equation was something like this, x plus 3 equals 1. If we're being told to solve this equation, what that means is we are trying to isolate our variable x to find what value for x makes this a true equation. So remember, isolating your variable means moving all of the other terms to the other side so that you get a statement like this, x equals -2. So this would be an example of what your answer would look like for solving an equation. Okay, so when you're asked to solve a quadratic equation, what you are doing is finding the values for x, which makes this a true statement. Now, if we look in our journal, there's 3 different methods that we're going to look at right now for solving quadratics. The first one is graphing, okay? Find the x-intercepts of the related function. So what we do is we graph our function and we find the x-intercepts. Now, I'm not going to go over how to graph a quadratic again because that's what we did last chapter. We talked about how to graph it. So if you need a refresher on graphing quadratics, you can go back and watch any of the previous videos. But in this, we're going to talk about what parts of the graph to look for. Now, here you'll notice that the x-intercepts are what we're trying to find on the graph. That's because the x-intercepts are the solutions to a quadratic equation. We have a couple other words that we use, root of an equation or zero of a function. Those all mean the same thing. Those are the points at which our equation is equal to 0, and they're the points at which our function crosses the x-intercept. So if you hear any of those different terms, that means find the solutions to the graph. So let's go back and let's look at the graphs for these functions to go ahead and plot them. Now, before you go ahead and find what function to plot, you have to make sure that all of your terms are on the same side and that your equation is equal to 0. Now you'll see our first equation is set up nicely for us already. In our second example, you'll see what we have to do to move it around. So here, once we've got all of our terms on the same side and it's equal to 0, we want to go ahead and rewrite this, replacing the 0 with y. So we've got our function to graph. So here's our related function, y equals x squared minus x minus 6. All we did is put all the terms on one side and then set it equal to 0 and then replace 0 with y. So this is now our function we're graphing. Okay, now again, we're not going to go through how to graph it. Again, you can rewatch some of the older videos if you need help on that. But let's go ahead and look at the graph here. So we look at this graph, we see it opens up, right, because our a value is positive. And here you'll see that it crosses the x-axis at -2 and at 3. So those are our x-intercepts right there, which means those are the solutions to this function. Now, we can test that by taking any of these values and plugging them back into our equation to make sure that they're true. So if we go ahead and plug in -2 for x, we see that we get 4 plus 2 is 6 minus 6 equals 0. 0 equals 0. That's a true statement. That's what I mean by finding a value that makes it a true statement. Same thing for 3. If we take 3 and plug it back in, we get 9 minus 3 is 6 minus 6 is 0. So we can check and make sure both of those are the case. You always want to check when you're solving by graphing, because if you don't just want to estimate what these points may be. If you find yourself estimating them, you always want to check to make sure you've got it right. So let's look at this second function. Here, you'll see that we don't have all of our terms on the same side. Okay, so before we can graph this, we need to figure out what function we're actually going to be graphing. If you tried to just plug in negative 2x squared minus 2 and graph that, you would get the wrong solution. We need to graph this entire function. So to get all of our terms on the same side, what we're going to do is we're going to move over. We're going to subtract 4x from both sides, so we get negative 2x squared minus 4x minus 2. We just subtracted this 4x. Okay? So now we replace 0 with y. So we have y equals negative 2x squared minus 4x minus 2. And we can go ahead and plot this function right now. So let's go ahead and look at the graph. Now we see that this graph opens downward, which makes sense because it's negative. And here you'll see that it only touches the x-axis at one point, at negative 1. So remember, your x-intercept, your graph doesn't always have to cross the x-axis at that point. It could be where it touches the x-axis. So here, our x-intercepts would be negative 1, so the solution or root is x equals negative 1. And again, we can check this by plugging it in. If we plug negative 1 in here, we get negative 2 times 1 is negative 2, minus 2 is negative 4, 4 times negative 1 is negative 4, so we get a true statement. Now notice, we've got, in our first example we had 2 solutions, but in our second we only had 1. Quadratics can have 2 or 1 solutions, or even 0. You're going to see some examples where there's no function, no x-intercepts. So if you graph your function, and for example, your function is something like this here, and there are no x-intercepts, it doesn't cross the x-axis at all, that means you have an equation with no solution. So you can either have 0, 1, or 2 solutions. So when you're graphing, you're looking for how many times does it cross or touch the x-axis. So what I want you guys to do is go ahead and look at these 3 problems right here and go ahead and solve those by graphing. Now you can use Desmos to solve these if you want. So if you go to desmos.com, you go ahead and open up the website, start graphing, you can go ahead and plug in your equations here. So for example, the first example that we did would look like this, x squared minus x minus 6, and you'll see you get your x-intercepts. So for these, if you want to use Desmos just to practice finding the x-intercepts, that's completely fine with me. So go ahead and find your solutions to these 3 equations and enter them in the text box now. I'm actually going to talk about the next method in the next video because I don't want to make this one too long. So go ahead and type those ones in now.